In this example, we have a piecewise function. It's f of x equals square root of x for x is less than 4, 3 when x is equal to 4, and x plus 1 when x is greater than 4. And what we want to do is examine what happens as x goes to 4 from the right and from the left. So we're finding the limit as x goes to 4 from the positive direction. That's what that plus means. And we also want to examine what happens as we approach 4 from the negative direction, which is from the left. We could examine these limits analytically, but in this situation it would be pretty interesting to just look at a graph of what all is going on here. So let's graph this piecewise function and see what happens. The point of interest in this graph is going to be x equals 4. That's where everything transitions between these three different kind of, functions, really, three different values. To the left of x equals 4, the function is square root of x. So that's going to come up like so. And then we stop and do an open circle, reminding us that the point x equals 4 is not included in that function. This is not less than or equal to here. It's simply less than. And then at the point x equals 4, we switch up to 3. So I'll fill in the point there. And then when x is greater than 4, we have the function x plus 1. Well, x plus 1 is a line. It's a diagonal line. So let's see here. It's a diagonal line that's shifted up 1. That's one way to look at it. So it's going to come up like so and go like this. Right. Let's see. That's up 1, up 1. 4 would go to 5. Okay, something like that. But we don't want it defined everywhere, right? It's only defined when x is greater than 4. So let's get rid of that line and then start it over just when x is greater than 4. So I'm going to start this. So let's see, it'll actually go up here. There we go. And then be a diagonal line going off like this. It's always good to graph piecewise functions. Even if you've done it before, it just keeps you sharp, right? You kind of have to think about these in a certain way. That's really good practice. Let's evaluate these limits. Okay, so for the first one, we're coming into 4 from the right. Okay, so from the right, this is x equals 4, so we're approaching it this way. So the limit as x goes to 4 from the right is 5. Right, we're approaching a y value of 5. So let's write that out. The limit as x goes to 4 from the right of f of x is 5. From the left, on the other hand, we're coming up like so. So looks like here we're approaching 2 as a y value. All right. So the limit as x goes to 4 from the left of f of x is 2. The last thing we'd want to look at here is the limit simply as x approaches 4. The limit as x goes to 4 of f of x. However, remember that the limit as x goes to any point a exists if and only if the right-sided limit and the left-sided limit at that point are equal. And we've already seen that the right-sided limit and the left-sided limit are not equal. So we would say that the limit as x goes to 4 of f of x does not exist. Often abbreviated as d and e.